Hi guys, welcome to my channel. In this video, let me explain the context-free grammar, derivations, and parse trees. Before going in detail, let me give the brief introduction. In the compiler design after lexical analysis, the next important phase is syntax analysis. Syntax analysis checks whether the sequence of the tokens follows the grammar rules of the programming language. Context-free grammar is used to describe the syntax structure of the programming languages and derivations, and the parser trees to help the parser to understand and represent the structure of the program. Let us go in detail with the slides and let us understand. The agenda of today's presentation: introduction to context-free grammar, and we'll see the components of context-free grammar. We'll see the example of context-free grammar, leftmost derivation, rightmost derivation, parse tree expression, parse tree example, comparison of the leftmost versus rightmost derivation, comparison of derivation versus parse tree, and advantages and application of the context free grammar, summary, and finally we'll end up with the conclusion. Let us go in detail with the slides. Context free grammar. What is context free grammar? It is nothing but it is a mathematical model used to define the syntax of the language. A context free grammar is represented as G equals V T P S. V is a variable or non-terminal which is represented like S, A, B, capital letters. T is a terminals. It is nothing but it is the actual symbol that appears in the final string. For example, A, B, identifier operators. P is the protection rules. Finds how non-terminals are replaced. Yes is the start symbol, the symbol from which the derivation begins. This is the example you can see. S produces the ASB or epsilon strings. AB, AABB, AAA, BBB. I hope you guys understood. Let us move on to the next slide. The components of CFG. Non-terminal. Non-terminals represents the intermediate structure. They're usually written in the capital letters. You can see S, A, B. Terminals nothing but the final symbol of the language, or it is an actual input symbol A, comma B, plus, minus, ID. The production rule defines the replacement. For example, S produces AB, A also produces A, B produces B. Start symbol is nothing but the first symbol of the grammar, that is S. You can see the example. S produces AB, A produces AA or A, B produces BB or B. I hope you guys understood. Let us move on to the next slide. Derivation. Derivation is nothing but which generates the strings by repeatedly applying the production rules. For example, we have this grammar. We need to generate AAA, BB. For example, S produces AB. Again, A produces, you can see, A, again, and B I kept as it is. Again, A produces, again A, B I kept as it is. Again, variable A replaced to the terminal A. Then B. Then B can be replaced to the BB. Again, capital or variable B can be replaced to the terminal B. You can see. The purpose is to verify the string and forms the basis of parsing. I hope you guys understood. Let us move on to the next slide. Leftmost derivation. Leftmost derivation is nothing but always replaces the leftmost non-terminal first. So you can see the grammar rules and you can see the steps. You can see the A can be reached to AA. Again, A can be replaced to AA. Again, A can be replaced to the A. Then B can be replaced to BB. Again, B can be replaced to the BBB. You can see from the leftmost non-terminal can be replaced first in the leftmost derivation. I hope you guys understood. This is basically used in the top-down parsing and recursive parsers. Let us move to the next line. Rightmost derivation always replaces the rightmost non-terminal first. Example, yes produces AB. B can be replaced to BB. Again, B can be replaced to small b, that is terminal. Again, A can be replaced to AA. Again, A can be replaced to the AA. Again, A can be replaced to A. Then we generated the expected string AAABB. I hope you guys understood. This is basically used in the bottom-up parsing, shift, reduce, or LR. I hope you guys understood. Let's move on to the next slide, that is parse tree. The parse tree is a graphical representation of the derivation. You can see the graphical representation of the derivation. The root node represents the start symbol. Intermediate nodes represents the non-terminals. Left nodes represents the terminal. Reading the leaf nodes from left to right gives the generated string. You can see this is the leaves, the generated string. The advantage, easy visualization and ambiguity detection. I hope you guys understood. Let us move on to the next slide. Expression parse tree. This is the grammar. Root node always represents the expression, that is E. The operator is plus and becomes the child node of E. Then the identifier becomes the leaf nodes. This is how the expression parser tree is represented. Let's move on to the next slide. The comparison, leftmost versus rightmost. Expands the leftmost variable for the leftmost. Right expands the rightmost variable. Left one is nothing but top-down parsing. Rightmost is nothing but the bottom-up parsing. Both produces the same tree. Hope you guys understood. Derivation versus parse tree. Derivation, the sequence of the rule application. Hierarchical representation, parser tree. Derivation, textual representation. Parse tree, easier to understand the grammar structure. Advantages and applications. Defines the syntax clearly. Supports the recursive constructs. Enables the parser generation. Detects the syntax errors. These are the advantages. Applications are compiler design, programming language uses this context-free grammar, XML and HTML parsing uses the parsing trees, etc. Natural language processing uses this grammar representation. I hope you guys understood. Summary: context-free grammar defines the language syntax. Derivation generates the valid string. Leftmost and rightmost differ only in expansion order. Parse trees usually represents the derivation. Thank you. I hope you guys understood. If you have any doubts, please raise your doubts in the comment box so that I can respond.